The SBSA keychain transform, orbital face permutations, and chained sphere cube pendants. When the Rubik lattice hangs from a carrier sphere like a key on a keychain, orbiting permutes the face labels. ABC carrier sphere times keychain ring times cube pendant. Aaron Cattell. Sixth in the SBSA series, extends. The SBSA planetary gear sphere, Section 26, Section 33. Abstract. The field sketches introduce a new outer transformation, not present in any prior paper. The entire 3x3x3 Rubik gear sphere lattice is suspended from a carrier sphere like a pendant on a keychain ring, and can orbit freely around that carrier sphere in three-dimensional space. We prove that this orbital motion acts on the Rubik lattice by cyclic conjugation of its face labels. Orbiting by 1/3 of a full revolution maps the face labeling ABCA, generating a cyclic group _3 of face permutation automorphisms on _Rubik. Multiple cube pendants can be chained to one carrier sphere, producing a bouquet structure, whose total group is a further wreath product. We formalize the resulting four-level group, compute its order, and prove that instantaneous address recovery is preserved. The orbital position contributes, at most, one additional stored integer per pendant. Section 34. The keychain construction. Every prior paper in this series treated the 3x3x3 Rubik lattice of carrier globes as a static combinatorial object embedded in abstract space, positions labeled, permutations tracked, but no physical attachment to anything outside itself. The new sketches change this fundamentally. The entire lattice is now a pendant. It hangs from a carrier sphere via a keychain ring, and can swing around that sphere through a full 360 degrees orbit. This is not merely decorative. The orbit of the pendant around the carrier sphere is itself a group action on the pendant's internal structure, because as the cube rotates around the sphere, the labeling of its six faces relative to a fixed external observer changes. Concretely, the face currently labeled A, pointing outward, becomes the face labeled B after a 1/3 orbit, and C after 2/3. A full orbit returns A to A, generating a cyclic permutation of period 3 on the face labels. Definition 34.1 Keychain carrier system. A keychain carrier system consists of a carrier sphere S² of radius are equipped with a designated equatorial ring, the keychain track. A cube pendant, the full SBSA planetary gear sphere structure of a 3x3x3 Rubik lattice of carrier globes, each carrying gear sphere clusters, attached to the keychain track at a single link point. An orbital angle phi set membership symbol 0, 2 pi, discretized to m steps of 2 pi m each, giving a discrete orbital group _m. ABC phi equals 0, BCA phi equals 2 pi, 3CAB phi equals 4 pi, 3 orbit by 2 pi, 3ABC a cyclic period 3 generates _3. Figure 1. 3 snapshots of the cube pendant orbiting its carrier sphere. At phi equals 0 the face ordering reads A, B, C. 1/3 orbit, phi equals 2 pi 3, gives B, C, A. 2/3, phi equals 4 pi 3, gives C, A, B. The orbit thus generates a cyclic permutation of the three face label classes. Section 35. The orbital face permutation action. We now make precise which group element each orbital step corresponds to. Definition 35.1 Face label permutation by orbit. Label the 6 faces of the 3x3x3 Rubik lattice as the A, B, B, C, C, where the bar denotes the antipodal face. The orbital permutation tau set membership symbol sim6, induced by advancing the orbital angle by 1 step 2 pi 3, is the cyclic permutation. Tau equals A/B/C, A/B/C, 35.1. i.e. A maps to B, B maps to C, C maps to A, and simultaneously their antipodal faces cycle in the same direction. Theorem 35.2. Tau is an automorphism of _Rubik. The orbital permutation tau acts on _Rubik by conjugation and is an automorphism for any face-turn generator f_a set membership symbol _Rubik, the turn of face A. Tau f_a equals f_b, tau f_b equals f_c, tau f_c equals f_a, 35.2. And cubed equals id. The subgroup generated by tau in _Rubik is _3. Proof. The Rubik group _Rubik is presented by 6 generators that are L, U, D, F, B corresponding to its 6 faces. Relabeling AR, BU, CF and their antipodals, the cyclic permutation 35.1 maps the presentation \Langle R, L, U, D, F, B \mid \text to Rubik relations a \rangle to itself by sending RU, UF, FR and LD, DB, BL. The Rubik relations are symmetric under this cyclic reassignment of axis labels, so the map is a group automorphism. Since the cyclic reassignment has order 3 faces cycle, RUFR, we have cubed equals ID. Section 36. The 4-level group. Adding the orbital layer produces a 4th level on top of the 3-level wreath product of 5. Definition 36.1. The keychain group. The full group of the SBSA keychain transform system is _KC equals _PGS, right semidirect product _3, 36.1. Where _PGS equals _n right semidirect product _m cubed _Rubik is the planetary gear sphere group from a 5, and the semidirect product uses the automorphism action tau of a 35.2 on the Rubik face generators inside _PGS. Theorem 36.2. Order of the keychain group. _KC equals 3 times _PGS equals 3 times _Rubik times _n right semidirect product _m cubed caret 27 with 36.2. Proof. By the standard order formula for a semidirect product, G right semidirect product H equals G times H when the action is well defined. Here _3 equals 3, so _KC equals 3 _PGS. The explicit value follows from Theorem 19.2 of 4 and Theorem 32.1 of 5. Level 4, orbital, _3 acts on face labels ABC by conjugation. Level 3, Rubik lattice, _Rubik permutes 27 globe positions plus reorients each globe. Level 2, carrier globe, _globe, _m cubed, rotates globe plus _gear caret K, _n, master spin. Level 1, cone gear sphere, _n spin times 1 SBSA address, S, T, W, V, per cone slot _KC equals _PGS, right semidirect product _3 equals _n right semidirect product _m cubed _Rubik, right semidirect product _3 order equals 3 times _Rubik times and times m cubed. Caret 27 address space 1.6 times 10 to the power of 1 times k times n times 27 by 3 locations. Figure 2. 4 nested levels of the keychain group. Each rectangle encloses the group acting at that level, from the SBSA address tuples at the core outward to the new orbital layer at the boundary. Section 37. Chained pendants, the bouquet construction. Image 2 of the sketches extends the single pendant construction to multiple cube pendants hanging from one carrier sphere, connected in series like keys on a keyring. Image 3 then shows a triangular arrangement, 3 carrier spheres each carrying a pendant, linked pairwise. We formalize both. Definition 37.1. Bouquet of pendants. A bouquet of p-cube pendants on one carrier sphere is a keychain system where p-pendants hang from p-equal spaced attachment points around the equatorial ring. Each pendant has its own orbital angle _I set membership symbol _M, and its own full internal group _PGS. The group of the bouquet is _bouquet equals _PGS, caret P right semidirect product _P, 37.1. Where _P cyclically permutes the P pendants around the ring. ABCBCA bridge ABCCAB globe 1, pendants A, B, C and B, C, a globe 2, pendants A, B, C, subscript marks second carrier. Figure 3. Two carrier globes linked by a bridge, each carrying two cube pendants. The subscript notation A, B, C distinguishes pendants on the second carrier from those on the first, matching exactly the labeling in the field sketch. Section 38 Address recovery in the keychain system. Theorem 38.1 Instantaneous recovery preserved. In the keychain system with P pendants, address recovery requires at most 6 stored integers per pendant. The 5 from Theorem 31.2 of 5 plus 1 additional integer k set membership symbol as 0, 1, 2 recording the current orbital position of that pendant. Recovery cost remains O, 1, independent of P, L, K, N, or total capacity. Proof. The orbital position, k determines which face label permutation, toe caret k, is currently applied. Given k, 1 applies toe caret k to the incoming face label query before passing it to the internal _PGS recovery chain. This requires one table lookup of size 3, 4k set membership symbol / 0, 1, 2 / plus the O, 1, 3-step pipeline of Theorem 31.2. Total, O, 1. Locate, A, pendant _I, equals toe caret k _I, A, _I, X, Y, Z, _I, 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 M _I slot, 38.1. Section 39 Summary, the 4-level architecture. Level. Object. Group. New operation. Stored integers. 1. Cone gear sphere. _N. Spin row. M master. 2. Carrier globe. _N right semidirect product _M cubed. Globe rotation. M alpha, beta, gamma. 3. Rubik lattice. _N right semidirect product _M cubed, _Rubik. Face turn. Plus sigma per globe. 4. Keychain orbit. _PGS, right semidirect product _3. Pendant orbit. Plus k per pendant. Every level adds exactly one new operation, and at most 1 or 2 new stored integers. O1 recovery is maintained throughout. References. Cattell, A. 2026. The SBSA sphere lattice. Cattell, A. 2026. Filling a sphere with cones from the center. Cattell, A. 2026. The SBSA hypercube as a rotation group. Cattell, A. 2026. 3-axis spin on the SBSA sphere. Cattell, A. 2026. The SBSA planetary gear sphere. Rokicki et al., 2014. The diameter of the Rubik's cube group is 20. Siam J., Discrete Math. Meldrum, JDP, 1995. Wreath products of groups and semigroups. Longman. 6th paper in the SBSA series. Formalizes the keychain orbital transform, proves it generates automorphisms of _Rubik, and extends the four-level group structure, with O1 recovery preserved.